And the reason why these are important is because everything we're doing, all the tools that we're learning, is gearing us towards what we're doing tomorrow, which is solving equations dealing with logs and exponents. Okay? Sometimes they give you an equation that has more than one log in it. And what you have to do ultimately is you have to condense it down to one log, then change it to exponential form to solve. But you can't learn how to condense 4 logs down to 1 log until you learn how they expand first. You have to be able to do back and forth. Okay? So first thing we're going to do is we're going to talk about these 3 properties of logarithms. First, if you have the log of 2 things that are multiplied together, you can expand that to the log of the first thing plus the log of the second thing. Now, they keep the same base. The bases don't ever change. Likewise, if you have 2 logs with different bases, you cannot condense them if they have different bases. They have to have the same base for you to be able to condense them. Consider them like terms. Okay? But multiplication expands to addition. And it works backwards too. If it's addition, it condenses to multiplication. For example, log base 2 of x times y. That expands to log base 2 of x plus log base 2 of y. Okay, that's that property. If you have the log of 2 things that are multiplied together, it expands to addition. Log of the first thing plus the log of the second thing. That's multiplication. Now we look at division. Division expands to subtraction. So if you have the log of something divided by something else, the log of m divided by m, n, that expands to the log of the first thing minus the log of the second thing. Your first log is your numerator. Okay? For example, log base 4 of x divided by y can be expanded to log base 4 of x minus log base 4 of y. So division expands to subtraction. Subtraction condenses to division. Okay? The third property is if you have the log of something with an exponent. Okay? The log of something raised to a power is sort of like an oxymoron. You can't have logs and exponents mixed. Okay? Because logs and exponentials are like, they're inverses of each other. So anytime you have the log of something that has an exponent, what this property says is you take that exponent and you move it out in front to where it's multiplied to your log. So the log base b of n to the r power is equal to r times log base b of n. For example, log base 7 of x to the third. Your final answer cannot have a log and an exponent together. So you have to take this and move it out in front. So that's equal to 3 times log base 7 of x. Okay? Any questions? All right. Okay. The first couple are already done for you. So the instructions say to expand. So they give you one log, and you have to expand them all to separate logs. Okay? So in example 1, we have log base 3 of 4 times x times y. Multiplication expands to addition. So that's log base 3 of 4 plus log base 3 of x plus log base 3 of y. Okay, so in the second one, we have x times y at the top. So that's log base 7 of x plus log base 7 of y. And then divided by z, so it's minus log base 7 of z. You'll notice that the first two, now they don't put parentheses around it, but our order of operations says that when you add and subtract, you go from left to right, correct? So it's understood that when if you needed to condense these, this would be log base 7 of x times y, and then that is divided by z. So this is going to become important when we start condensing, okay? Because they don't put the parentheses around it. So you have to use your order of operations to figure this stuff out. Okay, any questions on 1 or 2? Okay, let's move to number 3 and 4. Let's check your answer with number 3. So that should be, I'm going to write every step. You probably skipped this middle step. So this is log base 5 of x squared plus log base 5 of y minus log base 5 of c to the 4th. The last step is to move your exponents. Get rid of your exponents. So this is 2 log base 5 of x plus log base 5 of y minus 4 log base 5 of z. That is your final answer. Any questions on number 3? Now, with number 4, anytime you see a radical, you have to change that to a fractional exponent, okay? And up on the board, let's refresh our memory. The square root of x is the same thing as x to the 1/2 power, correct? The cube root of x is x to the 1/3 power. The fifth root of x to the 3rd is x to the 3/5 power, right? Okay, so if you have a radical, you need to change that to a fractional exponent. So this will be log base 6 of x squared y to the what? 1/3 power. Because it's the cube root of all that. That's to the 1/3 power. We can't put it all to the 2/3 power because it's just x squared, not y. But it's all to the 1/3 power. Right? Okay? Now, you are not going to move that exponent out in front. You need to simplify what's in those parentheses. How do we raise a power to a power? What do we do with them? You multiply them. When you have a power and you raise it to another power, you multiply them. So let's do that. So this will be log base 6 of x to the 2/3 power, y to the 1/3 power. The last thing you're going to do is move those exponents out in front. Let's separate them first. How do they get separated? Addition. So log base 6 of 2/3 of, log base 6 of x to the 2/3 plus log base 6 of y to the 1/3. Now that they're separated, we can move our exponents to the front. So it'll be 2/3 log base 6 of x plus 1/3 log base 6 of y. Now we're done. Yes. You can do it in one step if you're comfortable. That's fine.
I said no.
No, no, that's fine. I'm just showing every step so everybody knows where things are coming from. Okay? Any questions?
Divide by 3?
No.
Oh.
No. Okay. We have that radical. We need to write that as a fractional exponent. So that's everything underneath that radical to the 1/2 power. That's 3 to the 1/2 power. That's x to the 3rd to the 1/2 power. And that's y to the 1/2 power. Right? If you take the square root of a fraction, you do square root of the top and square root of the bottom, right?
Yeah.
Okay. So we're taking the square root of everything, which is everything to the 1/2 power. So this is log base 5 of 3 to the 1/2 power times x to the 3 over 2 divided by y to the 1/2 power. Because that's what square root is. Square root of x is the same thing as x to the 1/2 power.
Oh, wow.
It doesn't matter what variable it is. It doesn't matter if it's a number.
Why is that confusing?
Because it's x to the 3rd to the 1/2 power.
Oh, because there's
Okay? So that's the same thing as x to the 3/2. You don't need to. I was just refreshing your memory. Okay, so now we can separate them. The last thing we're going to do is move our exponents to the front. So that's log base 5 of 3 to the 1/2 power plus log base 5 of x to the 2/3 power minus log base 5 of y to the 1/2 power. Oh, I wrote it backwards. 3 over 2. Thank you. Yes. Now, the last thing we do is move our exponents to the front. So that's 1/2 times log base 5 of 3 plus 3/2 times log base 5 of x minus 1/2 times log base 5 of y. Okay, now we're going to go the other way. They're going to give you the expanded one, and you have to condense it to 1 log. You're not done until there's only 1 log there, okay? So, if the last thing we did when we expanded was move our exponents to the front, what do you think the first thing we're going to do when we condense? Put the exponents back where they belong, okay? You're literally working backwards, okay? So, let's look at number 1. This is the most important skill in this section is condensing, because this is what you're going to have to do to solve equations. Condensing the logs and changing it to exponential form are what you have to be able to do to solve the equations. Okay, so what's not the only exponent you see in number 1? That's the 5, right? So we have to take this 5 and put it back with the y. That's y to the 5th. So this is log base 2 of x plus log base 2 of y to the 5th. Addition condenses to what? Multiplication. The two things we're going to multiply are x times y to the 5th. So that's log base 2 of x, y to the 5th. That's condensed to 1 log. Number 2, this is a subtraction sum. Minus 1/4 times log base 4 of x. Now, remember, you can only condense if the bases are the same. Okay? If you ran into a problem, which you probably won't, but if they had different bases, you can't combine them. They're not the same. Okay? So number 2, we have log base 4 of y minus 1/4 times log base 4 of x. I'm here to tell you also, when you condense it down to one log, they don't want fractional exponents. That's not what they always start out with. They start out with the actual radical there. So when you end up with a fractional exponent, like x to the 1/2, in your answer, you have to put the radical back. Okay? So, my exponent in number 2 is what? 1/4. So I'm going to take that 1/4 and I'm going to put it back. That's x to the 1/4 power. So that's log base 4 of y minus log base 4 of x to the 1/4 power. Minus subtraction condenses to what? Division. Subtraction and division go together. So this is log base 4 of y divided by x to the 1/4 power. Right? The only thing we have to do is we have to put our radical back. So that's log base 4 of y divided by what? What root of x? The 4th root of x. We're done. We've condensed it down to one log. This is a y. I don't want anyone to think that's a 4. Okay, you know the problems aren't usually just simple. They're not two things like in the first two examples. There's usually going to be at least 3. Okay, this is what I was talking about, following your order of operations. Okay? There's no parentheses in number 3. So, we can just go ahead and put our exponents back first. Put your exponents back first. Now, ln, that's log, right? It's log base what? E. You just leave it ln. So that's ln of x to the 1/2 power plus ln of y to the 1/2 power minus ln of z to the 5th power. It's better already. Okay? Now, order of operations, if you're adding and subtracting, you work your way from left to right, correct? So that means you have to do these two first. Condense those two first, and then condense it with the third one. And you might think, well, that's dumb. She's making this problem longer than it should be. It is different when you have a subtraction first and then a plus. Okay? When you have a subtraction mixed in with the pluses, you trust me when I tell you, do the first two first and then do the third one, because it's easy to get mixed up with what goes in the numerator and what goes in the denominator. Okay? So when we condense these first two, these two are multiplied, right? So that's ln of x to the 1/2 times y to the 1/2. Okay? And it's that minus ln of z to the 5th. So we've condensed it. We took these two, condensed it down to 1. Now let's do those two. So it's all of this, x to the 1/2, y to the 1/2, divided by z to the 5th. So When we write it as one natural log, it's ln of x to the 1/2 y to the 1/2 divided by z to the 5th. Okay? Yes. Now we have to put our radicals back. If it's x to the 1/2, that's what root? Square root, right? So that's square root of x times the square root of y. Can I write them both under the same radical? Yes, because it's the same root. So it's ln of the square root of xy divided by z to the 5th. Okay, number 4. I'm going to let you try this one, but it already has a set of parentheses there. Simplify, combine what's in those parentheses first. Condense what's in the parentheses first. Now, notice there's no variables in here. It's all numbers. So when you combine them, those numbers will simplify. Okay? So you should have gotten ln of 9. That is my favorite number. Okay, so simplify within parentheses first. You could distribute that 2 and be 2 ln 18 minus 2 ln 3, but you're creating more work for yourself. Because then it would be ln of 18 squared minus ln of 3 squared, and then you just don't do what's in parentheses first. So this is 2 times ln of 18 divided by 3 plus ln of 1 over 16 to the 1/2 power. Right here, I put the exponent back. That's 1/2 times ln of 1 over 16. Now, it doesn't matter to me that there's a whole bunch of fractions in here, because these are numbers, and I have a calculator that can calculate those fractions for me. Now, 18 divided by 3 is 6. So this is 2 ln 6 plus 1 over 16 to the 1/2 power. That's the square root of 1 over 16, which is 1/4. So ln of 1/4. Because 1/16 to the 1/2 power is equal to 1/4. Okay? So, now this is ln of 6 squared plus ln of 1/4. 6 squared is 36. So this is ln of 36 plus ln of 1/4. Addition condenses to multiplication. So that's ln of 36 times 1/4, which is ln of 9. Page 496, 31 through 55. I expect you to check your answers. I also expect to see the work on tomorrow's homework. You cannot have just an answer and say, oh, I condensed it all in my head. No, I want to see the steps. Okay?